Repair work is similar to detective work, so before we tear into this thing, let's take a moment to observe the dryer's symptoms. Is there a strange noise? Is the dryer not heating at all, or not as well as it should be? Does the dryer heat for a few minutes and then go cold? In this chapter, we will be troubleshooting heating problems. First, check the obvious. Is the dryer getting gas from the house? Something as simple as improper installation of Teflon tape could be greatly reducing your gas flow. You should know that the gas valve is on and that gas is in the flex line. Some gas connection fittings need to be installed in the proper direction or can close internally, blocking gas flow. While we're back here, let's disconnect the ducting from the dryer. Many times the ducting from the dryer to the wall or the ducting within the house can become clogged with excess lint. This can cause your dryer to take a very long time to dry a load of clothes. In extreme cases, dryer fires can occur. Often long dry times can be solved by simply disconnecting the dryer's duct and running a test load. If the dryer now magically works, check the ducting for blockages. Dryer manufacturers often suggest limiting ducting length to no more than 10 feet, and each 90-degree angle in the home's ducting is like adding 5 feet to its length. Vertical home ducting can also be a common source of clogged ducting and heating issues. One more thing to consider. Could your dryer be getting a bad rap because of your washer's inability to spin? You should not be able to wring water out of fabrics at the end of your washer's spin cycle. Poor spin speeds often can mislead people into thinking that their dryer has a problem. So let's look at a properly functioning dryer, and then we will be better prepared to notice problems. To observe the burner, look for a small cap located on the front left of the dryer. This cap is a viewing port for observing the burner assembly. Remove it with a flathead screwdriver from the tab on the bottom. Now we can start the dryer on a cycle that will require the dryer to engage the burner. You want to avoid cycles like no heat and air fluff. We are waiting to see if the burner igniter is going to glow. Knowing this will help us to cut the possible causes of a heating problem in half. If the igniter glows, we know that it's okay. We also know that the thermal fuse in the back of the dryer is okay as well. Next, we will want to see if it turns off. If it didn't glow, don't worry, we'll troubleshoot that option in a moment. If the igniter clicks off after a few seconds of glowing bright orange, you know that the flame switch mounted on the left side of the burner tube is okay as well. At the moment that the click of the flame switch is observed, the burner valve should release gas for burner ignition. If the igniter turns off with no ignition, and you are sure that you have gas supply to the dryer, then you likely need to replace the 2 coil valve solenoids on the top of the burner. In extremely rare cases, the valve may need replacement, but the coils are a safe bet. These safety coils may gradually fail over weeks or even months, given partial heating and long dry times. As safety coils are going bad, they will work properly for a short period of time. Then after a half an hour or so of cycling on and off to maintain the drum's temperature, they will break down and cease to open the valve, resulting in cool or wet clothing at the end of the cycle. If the igniter glows but never clicks off, you likely have a bad flame switch, also called the flame sensor. But let's just say that your igniter never heats up. For this one, we're going to dig a little deeper. We will want to look at all the possibilities in order of likelihood. First, unplug the dryer. Next, remove the back panel of the dryer. The back plate is held in place by a series of 1/4-inch screws. For more detailed information about opening the dryer or removing and replacing components, watch the video Deconstructing the Dryer, available at applianceassistant.com. Once the panel is off, you will see some wiring, a few sensors, and a fuse. The fuse is what we want to test. The dryer fuse is a small white strip mounted near the center of the dryer with 2 wires attached. This fuse is designed to burn out when it senses that the dryer has reached an unsafe temperature. So, if you find it to be the problem, you will again want to make sure that the ducting is flowing out of the house unobstructed. You will also want to verify that the dryer is cycling properly after you replace the fuse, or you may have a bad cycling thermostat. We will look more closely at how the cycling thermostat works in a moment. The safest way to check this fuse is with a voltmeter. These are fairly low-cost items starting around $10. So make sure that the dryer is unplugged and then remove the 2 wires attached to the fuse. Next, set your voltmeter to measure the fuse's resistance by changing the setting of your meter to the omega symbol. For more information on how to use a voltmeter, visit applianceassistant.com. With the wires removed, contact the two terminals of the fuse. You should get a reading of 0 resistance, the same reading you would get if the two leads were touching each other. This shows that the fuse is allowing power to pass through it and onto the igniter. If the fuse tests open, replace it, and if not, let's keep looking. Leave the back off, we may need to access those parts later. But now we're going to lift the top and remove the front. From inside the dryer, we can see the burner valve, the valve coils, the igniter, and the flame switch a little more clearly. Okay, so we're going to assume this time that the igniter is not glowing and that we've tested the fuse in the back of the dryer and the fuse was good. So now let's test the flame switch and the igniter. Unplug the connection to the igniter and check the igniter contacts in the same way we did the fuse. This time, depending on the sensitivity setting on your meter, we should measure a small amount of resistance causing the igniter to heat up as electricity passes through it. We should not get an open circuit reading. This would tell us that the igniter is broken and unable to heat up. If the igniter tests good, plug it back in and disconnect the wires to the flame switch. Test it in the same way we did the fuse and the igniter. This should look the same as the fuse, a closed circuit, meaning 0 resistance, meaning power can flow through freely. Any part that tests bad should be replaced. If all of these components test okay, rinse and repeat, meaning check it again. If all of these components actually are okay, then we're out of the common 90% of dryer heating problems and are moving on to advanced troubleshooting. You will need to find the dryer's wiring diagram to find where the circuit is having a problem. The wiring diagram is usually located behind the back panel of the control console. This may be a little intimidating, but with a voltmeter and some patience and some basic understanding of how to read wiring diagrams, you will be able to solve almost any problem. Remember, practice makes perfect, and this is not a one-time thing. You will be able to use these techniques again and again in other applications, so stick with it. Let's look at the wiring diagram. As we can see, the left side of the wiring diagram is the black power supply, while the right side is the white neutral power return. The power will always move from black to white like water moving downhill. Any break in that path will stop anything in that chain of components from functioning. Your wiring might be slightly different, so you will want to check your wiring diagram. By this, we can see the power is supplied to the burner from the red wire attached to the timer. It circulates through the high-limit thermostat, the thermal cutoff, and the operating thermostat, as well as the thermal fuse before reaching the burner. The electricity then takes the path of least resistance through the flame sensor instead of the coils located on the valve, which offer resistance. The igniter heats up, opens the flame sensor, which is a bimetal thermostat. At this point, electricity is forced to move through the coils opening the valve because the flame sensor is open. This will continue until the operating thermostat opens because the dryer has reached full temperature. The circuit is broken, blocking electricity from reaching the coils, operating the valve, and cycling the burner off. The flame sensor cools down and closes again, causing a clicking noise. When the cycling thermostat closes again, the igniter will again be energized through the flame sensor and the process begins again. Let's take a closer look at how the cycling thermostat works. There are many different dryer models. All will have at least a high heat and a no heat or air fluff option. Many will have other options like low or medium heat levels, as well as more dry and less dry settings. The cycling thermostat is what is called a bimetal thermostat, which means it contains two small strips of contact material that flex at a particular temperature to open and close the circuit automatically. Open means no electricity can pass, and closed means it can pass freely. If this only happens at one temperature, how can the low and medium temperature settings work? Well, as we can see in the wiring diagram, models with other temperature options have a thermostat heater. Depending on the setting, more or less voltage is supplied to this heater, which is attached to the dryer's cycling thermostat. Low setting would supply more voltage, creating more heat, and a medium setting, slightly less voltage, generating less heat. And high settings would not energize this thermostat heater at all. In this way, the thermostat is tricked into thinking that the dryer is hotter than it actually is, and opens at a lower drum temperature. Problems with this system can occur when the temperature selection switch fails to send the proper amount of voltage to the thermostat heater, or the heater itself fails to heat the thermostat. This is very rare, but it can happen. A resistance check across the thermostat heater might shed some light. If the heater offers infinite resistance, meaning an open circuit, it will need to be replaced. It should provide a small amount of resistance to create the heat required. We can check the entire chain of components responsible for burner operation except the coils by unplugging the dryer and measuring resistance from the red timer contact to the neutral plug prong, which is the right prong if it's pointed at you. For this to work, the red timer connection must be disconnected or you may get a false reading through other timer contacts. The door switch must also be closed. If you have that disconnected, you can still check from the red timer terminal to the blue connection on the door switch. We can also see that after the black wire leaves the igniter, it passes by the motor through the push-to-start switch. You only hold the switch for a moment, so how does the dryer continue to run after I let go, you may ask? Good question. The symbol to the right of the motor is a centrifugal switch, meaning that when the motor spins, the centrifugal force of that spinning action causes contacts to expand outward, breaking contact from the start windings and rerouting power through the main windings. Continuing the connection to the black wire, electricity flows through the closed door switch, finally becoming a white neutral connection. It then completes its path back through the wall plug to the neutral connection in your home service panel. For this test, because the motor is not running, you will need to press and hold the push-to-start switch. An infinite reading means a break in this circuit. There you have it, the magic demystified and made clear. Now after you fix your dryer, remember to help others with your newfound knowledge. I hope this information was helpful. Visit applianceassistant.com for more information. Thank you for watching.